Guys, in this video, we're going to look at recursion, and we're going to look at recursion, and we're going to solve a problem. Actually, solve a couple of problems using recursion. So again, from my lecture slides, uh, the two most important ideas regarding recursion is this idea that you're taking this problem of size n, and what you're trying to do is you're trying to reduce this problem of size n into a smaller problem at every recursion step. Okay, so again, please open up my lecture slides, and it'll be easy to follow along if you get that first two important ideas regarding recursion. And as this problem size n, as this original problem size of n gets smaller and smaller, n minus 1, n minus 2, n minus 3, it doesn't need to be even linearly this way. It could even be n divided by 2, n divided by 2, and so forth. The idea is it should get smaller. As it's getting smaller, it should converge to a point where that small problem could be solved using non-recursion. Okay, so these are two important ideas regarding recursion, and what I would like to do in this thing is keep it really hands-on, in the sense that let's take a problem in Python and let's see if we can actually solve this using some code. So let's create a function. This is something right from a lecture slide. So I'm going to say find the sum. Find the sum of my sum of the list. Okay, so what it does, it takes in a local variable xs, which is basically a list of something. In this example, it's basically a list of integers. And what I'm going to do is if the len of this xs if the len of this xs is actually 0. If it is 0, meaning something has gone wrong, meaning I cannot even compute the sum of my list at this point. I'm going to say something has gone wrong here. I'm going to give back an error. Okay, this is something, a problematic piece of code here. So I'm going to raise an exception. So I'm going to say raise. Again, it's just getting really generic right now. Okay, so I'm just going to say this is an empty list. Otherwise, if my len of my access is actually 1, if it is actually 1, meaning that I have a list of one element. I have a list that has at least one entity in it. If that's the case, then the sum of all the elements in my list is just going to be whatever is excess of 0. All right. Otherwise, if the len is something that happens to be greater than 1, okay, if it's actually greater than 1, well, in that case, then I'm just going to have my recursion, and I'm going to say return excess of 0 plus. Okay, I'm just going to take the first element of my list and add it to whatever is the summation of the remainder of the list. Meaning, this is going to be excess of 0 plus sum of list of excess of 1. Okay, let's just think about this a little bit more clearly. Okay, so let me do this. Let me get my pen drawing. And what we're going to do now is this is run through some examples. What if excess? What is excess equals to empty list? Let's just take the empty list. If excess is the empty list, okay, if excess is the empty list, then what is the len of excess? The len of excess is actually 0, meaning len of excess is 0. 0 equal to 0 is true. This condition becomes true, and then you're going to raise an exception. You're going to raise an exception saying that this is an empty list. So what this piece of code is doing is throwing an exception. Raise or throw are completely equivalent statements. It's throwing an exception. But throwing to who? It's throwing to whoever called sum of list. Whichever code calls sum of list, that code is going to get that exception. All right. What if excess is actually, let's do this. Let's work through a second example. Second example is when excess equals to a list of just one element. What does that mean? Okay, so excess now is a list of one element. Is the len of excess equal to 0? Well, len of excess, this code over here is 1. Is 1 equal to 0? Well, that Boolean expression is false, meaning this doesn't get executed. We come back over here. Okay, what is len of excess? Len of excess is actually 1. 1 equals to 1. This Boolean expression right there is true. If it is true, what you're going to do, you're going to return back excess of 0. This is what excess is. This element over there is at index position 0. So what is excess of 0? Excess of 0, this whole thing is actually equal to 1. And it makes sense if a list that contains one number the summation of all those numbers in that list is that number itself. So I'm just going to return back excess. This just returns back the number 1, if this is my example. If the list was with one element, let's say 5, then this would return back, 5. And you get the idea that I'm just returning back that element itself. Otherwise, if I have a length of excess that happens to be more than 1, meaning I have something, let's just do this again. Let's say my excess now is basically 2 elements. Let's say 10 comma 5. Okay, this is 10 comma 5. This condition is false, this condition is false. I come back to the return statement. What is the return statement saying? It's saying that the summation of this list is nothing but the summation of excess of 0, which is 10. So this piece over here is 10 plus, I'm just writing the plus as it is, plus sum of list, and inside the function, what is excess of 1 colon? It means the list with starting with the next element, meaning this is a list with the element just 5 in it. And that makes sense. I'm just saying that the summation of this entire thing is nothing but the summation of the first element of this list, which is 10, plus the sum of the remainder of the list with 10 taken off, which is the list that contains just 5. So if you can tell me what is the sum over here, if you can tell me the answer to this thing, whatever the answer to this is, I'll take that answer and add it to 10, and that entirely will be the solution to the problem of getting a summation of all of these excess. Okay, so let's just write this code. Let's just debug this and let's see how this works out. So now if I say sum of list, and let's say just pass in first the empty list and see what happens. If I take this, if I run my code, and there you go, I'm getting back an exception. Okay, but why did I get all of this jargon here? So if you're following along from my second video, which was regarding exceptions, remember this piece of code isn't inside a try catch, so that's why this is all getting thrown at me. So what I should appropriately be doing is I should be doing try and then say accept, and I'm just catching a generic exception right now and say you have given me an empty list. There you go. So now let's run this once more, and it's much more cleaner for the user. The user sees, oh, I ran this thing, I get back an empty list. All right, something went wrong, and now I know what to do with it. All right, good. So let's work on this problem slightly. One more use case. Let's pass in number 5 and see what happens. So if I run this, of course, I'm not printing this output anyway, so I need to print this. I'm going to say print the sum of my list. Let's give a nice user message. The sum of my list is so and so. All right, and I need a comma there. All right, a little bit better. Let's just run this once more and see what happens. Okay, so now I get that the sum of my list is 5. Okay, so if I pass in a list that contains only one element, the summation of the list is 5. Okay, so far so good. Let's put 5, 10, and 15. Okay, what's this? 15 plus 10 is 25, 20 plus 5 is 30. Let's run this and I get back 30. So, okay, this is good. So far, this makes sense. Okay, let me show you exactly what's happening inside this. Let's make it a little bit interesting. Let's put a breakpoint. What's a breakpoint? Breakpoint is that piece of my instruction where I would like my program to momentarily come to a pause. It's not going to terminate at that point. It's just going to come to a momentarily pause. It's just going to pause there, telling me these are the state variables. This is what my program looks like at that point, and I can then tell execute the next instruction and so forth. So I'm just debugging my code, but I'm placing a breakpoint. So now what I'm going to say is I'm going to right click. I'm going to say whenever you hit this pink line, stop. Just momentarily come to a pause, and I would like to see what my code looks like at that point. So how do I do that? How do I instruct Python to do that? So I'm going to right click on learning exceptions. I'm going to say debug learning exceptions. The program is going to start running, and there you see something has happened here. Something has happened telling me that this program has come to a halt. Okay, what does that mean? If I were to take this window and more specifically, if I look under the variable section, I can see right now that this excess this excess is currently equal to 5, 10, and 15. Okay, that's good. I can see that my excess is currently 5, 10, and 15. Why is this line getting executed right now? It's because this line was false. This was false. Both were false. It went inside the else block and it's about to execute this line. Okay, and more specifically, I can see inside this frame section. Think of frames right now as a stack. Okay, this is nothing but a stack over here. And what this tells you, the stack. Okay, so what the stack tells you is currently the method that is in execution is this piece right there. Okay, how do I know that? Because this is the topmost item of my stack. Just ignore these guys. Okay, let's not even worry about these guys. Okay, so I just want you to ignore the thing over here. Okay, and what I'm saying here is that my module which is learning exceptions.py, which is that module, on that module, on line number 11, which is this is line number 11 right there, on that module, on line number 11 a function got called sum of list. Okay, that makes sense because I'm calling sum of list right there. So within the module learning exceptions.py, on line number 11 a function sum of list got called, which is this piece here. This sum of list also happens to be in the same module. It happens to be in the module learning exceptions. I'm on that sum of list. I'm currently on line number 7, which is this line number 7 here. So that's line 1, that's line 2, that's line 3, that's line 4, 5, 6, and 7. There you go. So I'm currently on line number 7. And I momentarily come to a pause. At that point, as I've come to a pause here, this local variable access is currently equal to 5, 10, and 15. Okay, good. Now, what do you expect? What do you expect on this line to do? Well, this line is again calling sum of list. What do you anticipate this picture to look like? Well, what I would anticipate is if this module, the first module, which is right here on line 11, called sum of list. This sum of list again calling sum of list. So I should get back another stack frame, something like this over here. I should get back another stack frame which should have sum of list, which is inside learning exceptions.py, and this line number 7 called it. So I'm going to see another stack frame where sum of list is calling sum of list again. So let's just see that. Okay, so let's kind of let's step inside the function. So to step into the function, I'm going to use the keyword or this key on PyCharms, which is F7, and let's step into this. So you see that it has gone inside sum of list again. Look at what has happened here in my stack frame. In my stack frame, I see that the first sum of list, which is right there, called another sum of list right there. But in the second sum of list, excess is actually 10, 15. In the first sum of list, excess is 5, 10, and 15. Remember, excess is a local variable. The scope and the visibility of that variable is within the function that is actually defined. So in this function, sum of list, the first one, excess is 5, 10, and 15, and the second one is actually 10, 15. So let's just step through this function. Let's just go line by line. So if I step, that's false, it comes back over here. What does sum of list do again? It calls sum of list again with excess of 1 colon, meaning that it's going to drop 10 and it's going to pass in excess of 15. So let's step into this function. And there you go again. Sum of list, first sum of list had 5, 10, 15, which called a second sum of list which had 10, 15, which called the third sum of list which just had excess of 15. At this point, what is the length of excess? The length of excess is 1, meaning this code should execute, that line should execute. Let's see that. So if I step over, I come there. If I step over again, there you go. That line is true. The length of excess of 15 is just 1. I return back excess of 0. But where does excess go back to? Where does it go back to? This 15, remember I'm currently over there. I'm currently inside this sum of list right at the very top one, which has excess 15. What is excess of 0? Well, excess of 0 is just the number 15. So what does this return? This returns back just 15. Who does it return back to? It returns back to whoever called it, meaning this function right there, the next subsequent one is what called this topmost sum of list. So that 15 is going to go down one level, one. It's just going to return back to the next outer sum of list method. Okay, so it comes back over there. It comes back over there 15. So let's do that. So if I step over, first thing, remember, this is a point when this sum of list is going to get completely returned. So far, this sum of list did not return because it called itself again. It called itself again. This is a point where I hit the base case. This is a point where I'm solving it non-recursively, meaning I'm going to return and going to return from the topmost stack frame. So now if I do a step over, if I do a step over, look at what's going to happen here. I have three sum of lists currently executing. If if I return now, one of them got taken off from the stack. It popped off, meaning I have two currently executing. But where did it come back to? It came back to the next sum of list. At this point, what's interesting is that this entire thing that returned back from this entire thing is equal to 15. Remember, we had 15 from the previous recursion that was solved non-recursively. What is excess of 0 now? Excess of 0 is 10 right there. That is my excess currently inside this sum of list is currently 10. 10 plus 15 is 25. So when am I going to return 25 now? This 25 is going to go back right to the next stack frame. Okay, so this stack frame is just about to get popped off because I'm going to hit the return statement. When I hit the return statement, this guy gets taken off, this guy gets taken off, and when it gets taken off, it comes back to the previous stack frame. So let's see that. So let's do a step over. So if I come back over here and if I do a step over, that got popped off. I came back to the next sum of list, and what's happening at this point here? What's happening at this point is that all of this code which got returned previously is now 25. What is excess of 0? Excess of 0 is 5. Alright, so 5 plus 25 is actually 30. Is 30. I'm going to return back 30, but who am I going to return back to? I'm going to return back 30 to whoever called it. That 30 is going to go back down to the module learning exceptions, most specifically on line 11, this is line 11 right there. Is going to come back 30. This entire thing, this entire function right there is now going to be 30. So I'm going to see an output. The sum of my list is 30. That's what's going to get printed. Alright, so now if I do another step over, I'll come back to my print function. Let's see what happens in the console. And I'm going to see the sum of my list. That's 30. Alright, so I hope this was useful, guys. Again, my lecture slides have these things more in detail. We have more numerous examples, but I wanted to have one specific example where we do this using actually on Python, and we see exactly what happens on the debug window as these multiple recursion happens and when these recursions get taken off. So again, I'm hoping this was useful, and if there are any more videos that you guys like me to make, please by all means shoot me an email, and I'll be more than happy to cover some of these advanced topics a little bit more with clarity in the video. Thank you.